Well, the value of computational models, in particular social computational models, is that it helps you in getting grip and an understanding of how interactions between people play out. And it helps in thinking about the dynamics that take place in societal change. For example, if you want to go to a more plant-based diet or to another energy system, but also small-scale changes like we do study in our Smart East project. For example, if you want to have a street car-free, or you want to have a heat network in a town, that requires the collaboration and interaction of groups of people. And it's very easy to stand on the side and to have some comments on that. But it's better to be capable of simulating these dynamics, because that opens up the possibility of exploring what kind of supportive policies you can think of in making a transition to a more sustainable situation more smooth. It helps you also to identify if there are possible problems like polarizations happening in society and what you can do about it. So I think it's a methodology that helps you getting a deeper understanding of the dynamics and how we can respond to that. Yeah, I think a very hot example would be the outbreak of a virus in a pandemic situation. And just imagine you have a limited supply of vaccine. And the question is who to vaccinate first. The spreading of a virus is first of all a very social thing. So it spreads from one person to another. Which persons in a social network should be vaccinated first to slow down the spread of a virus? And my good colleague Josh Epstein from the Johns Hopkins Institute found out that it's very important to focus first of all on hospital workers. Because if people come to the hospital and they are ill and they infect hospital workers, the hospital workers go home and infect, for example, their children or their spouses. And that plays an important role in the fast spread of the virus. If you block that, you already have one good strategy of reducing the spread. And this is typically something that could be learned from experimentation with these social simulation models. The effectiveness of social simulation is that you can very quickly implement characteristics of the virus into an artificial society and see what kind of strategies would work and what strategies are less effective in containing the virus. So it offers you a kind of lab that is very quickly opening possibilities of testing policies. You cannot do that in real life, There's only one world. But if you have a simulated world, you can conduct a lot of experiments very quickly and find out what are the more effective strategies to contain a virus.